Okay, am I audible now?
Yes, audible.
Okay. So we were looking at auto-scaling groups and creating alarms and creating auto-scaling policies and alarms and dashboards, right? What was the main reason why we were looking at auto-scaling groups and alarms? So, see, this is our DevOps tool chain, right? I mean, where we say plan and then code, then test the application, deploy the application, deploy the build. Here we have a build, deploy, operate, and monitor. So basically, we need to have monitoring in place that is done by operations team. As a DevOps, our responsibility is to create the monitoring solution, not monitoring the application completely. The infra engineer or DevOps engineer's task is to infra DevOps or application DevOps engineer task is to create required monitoring based on the SLA provided by the customer. SLA we agreed with the customer, be it creating an alarm, be it creating a dashboard, be it creating sending out notifications. All those basic infrastructure related stuff that we need to do, whereas the actual monitoring will be taken care by the operations team, not by the DevOps team. When I say operations, there are different people involved, like support, SRE, uh, and especially application support and SRE team people will be part of the operations team. They will take care of continuously monitoring the system, supporting the customer, and looking at the different issues customer is reporting or customer is experiencing. Okay. Now, why we are looking at auto scaling? Any clue why we are looking at auto scaling when we talk about monitoring, right? Why? What is the need for auto scaling? Can anyone give me an answer quickly? Okay. When there is a spike, say 80% CPU utilization. So what would happen? Definitely the system will hang. System will not run properly. System will hang. What you are supposed to do as a DevOps engineer, you are supposed to add more instances so that you are able to fulfill the request which is coming from the customer. So we have to do auto scaling, and then again you cannot really just to keep auto scale up, right? At any point in time, the load might decrease, load might come down. So in that case, you are also supposed to remove the extra added instances. You are supposed to have only the decide count running. That is why we have auto scaling. Auto scaling configured for two things. One is for say like Ganesh, your question will be answered now. One is like vertical scaling, where you will add more EC2 instances. Even though here it is on the cloud, it can be still called as horizontal. But logically speaking, if you're adding more CPU, more memory as a complete device, complete compute, then it is called vertical scaling. Whereas horizontal scaling talks about only adding more services. Like in container world, we call it as task or we call it as pods. So in order to just fulfill the customer request, we can keep on adding pods based on again auto scaling policies. Auto scaling policies talk about what is the CPU utilization or memory utilization of the particular container which is running. Any doubts, any questions on this so far?
Cost effective point of view, what is the best method?
Uh, can you just repeat the question?
Cost effective point of view, what is the best method for this?
So cost effective is always have an auto scaling up policy and auto scaling down policy. I mean, it's called scale out and scale in. So we are supposed to have scale out as well as scale in policies if you are talking about auto scaling. If you just think about only scale out, then you will end up probably having, because of a sudden spike in the number of customer requests, you might end up having, instead of 4 instances, you might go to 12. But if you don't have a scale in, you will probably bear a lot of cost. You'll have to end up paying a lot of cost for your cloud resources. So the best practice is always having both scale out and scale in configured in your auto scaling policies. Clear?
Got it. Yeah.
Any other questions, anyone?
No, sure.
Okay. Moving on. See, this picture you would probably understand right now, because this is a minimum size. Whatever you feel like, whatever you want to have, that is a minimum size. Desired capacity is also always minimum. When the load increases, say you are increasing the instances by 2, right? In that case, your desired capacity becomes 4, because your minimum capacity was 2. Sorry, it was 4 before, now it is 6. Okay, minimum count was 4 and desired count was 4. And because of auto scaling, you have increased the number of instances to 6, and you still have minimum 4, maximum say 12. So at any point in time, even if this increases, usually the desired count becomes 8. Then desired counts become 12. It keeps on increasing. Then beyond 12, it cannot go, because that is a maximum capacity that we have chosen. It is not possible to go beyond 12. In case if your system still behaves badly, if your system still has more CPU utilization and things like that, it is very difficult. You have to manually intervene and then do some operations on that. So ultimately, whatever based on your experience or based on your customer inputs, you will probably have the maximum number of instances running to the maximum. So it will never be a problem. Again, once the peak load comes down, say for some reason, the number of requests going to the servers are less. In that case, it'll automatically come down to 8, come down to 4. So at that time, the desired capacity will be reset. When it is cutting down the number of instances, automatically the desired count will become less. And it will never go below 4, because your minimum count is set to 4. That is how auto scaling group works. Even auto scaling policies for services work. You will always have a desired minimum
Shankar,
count.
so one doubt.
Yeah.
So desired capacity and minimum capacity will be the same, right?
When it is at the minimum. When it is increasing, say when there is a +2, right? Because of the desired capacity becomes 6. Because at that time the desired running count is 6. Otherwise, if it is not set to 6, it will not spin up more instances. What exactly happens is, say when there is a CPU spike, right? Your desired count set to 6, so that it can add more instances, depending on the scaling policy. If you have a step scaling policy, we'll look at it later. If it is a step scaling policy, if you want to add 2 instances, you can add 2 instances. In the step scaling policy, if you want to add 1 instances, you can add 1 instances. Based on that, the desired count on your auto scaling group will be set to that particular number. So how it works is, I mean, the minimum is always kept 4, and the desired also kept to 4. And when there is a request, the desired count is increased to the required amount, and then automatically the scale up will happen. Clear?
Okay.
Any other doubts, questions, anyone? see basically why we require autoscale. That is to monitor the health of the running instances, not just like configuring autoscaling group, also configuring alarms or metrics. Without metrics, it is very difficult to configure your autoscaling. So custom health check, load balancing across availability zones. For this, we need to use application load balancer. So these are the other advantages, but we can see the spot instances. We can see other type of instances also in autoscaling groups. So scalability, instance refresh. That means if there is one faulty instance, that will be removed, and then there will be new instance added. So in case anything goes wrong with a particular running instance, it will be removed. A fresh instance will be added. So autoscaling group is collection of instances that we already saw. Autoscaling group is nothing but collection of EC2 instances of a similar type. Here, launch template we already saw. It is all about grouping the instance configuration, like your EMI, instance type, your key, and things like that. What is scaling policy? Based on what policy the number of instances will be increased or decreased? It could be a target tracking policy. Target tracking policy I already explained. If you have 3 instances running, total number of instances will be called as target. If there are like 3 instances, 1, 2, and 3, if you set to 50%, and overall average of 3 CPU utilization goes beyond 50, then only instance will be added. So that is what is called target tracking policy. It is not going to check whether 90% is one instance, the other instance is like 20%. So 110, if it is like 30% here, then it is not going to add any new instances, because overall it is less than 50%. That is what is target tracking policy. Target means the total number of instances running inside your cluster. That is what is a target. What is a health check? We always have, similar to the heartbeat, we'll always have some request going to the particular server, checking whether that particular service is running or not. It is like health check for instances that will look for some particular service, whether it is running continuously or not. If something is down, something is not reachable because of some reason, if something is not reachable, it will make it to unhealthy. So that that instance can be removed immediately, and then new instance will be added. Okay, what is the purpose of load balancer? Like I said before, load balancer, the purpose of load balancer is to do fault tolerance. How do we identify there is an instance is unhealthy and we have to avoid sending requests to the particular instance? That is taken care by only the load balancer. Load balancer does the job of fault tolerance. Any doubts?
Shankar, these health checks and load balancer will notify on their job, like for example, if the instance health is not good, something is going wrong, is it notify? Will notify?
Yeah, so they will have internal connection between the load balancer and health check. So load balancer will understand there is a problem, and health check, based on the health check, the autoscaling group will spin up new instance, because that instance will go down because your desired count is set to 2, right? Say if your desired count is set to 2 and one instance is not running, not behaving correctly, that will be automatically removed based on other policies set in the autoscaling group itself. There are some configuration that I'll show you. There is one timeout value which is there. So based on that, it will remove the instance and it will add a new instance. So it is kind of integrated completely. Like scaling policies, auto scaling group, health check. All of these things are integrated. They all work together. They all work in tandem.
Got it. And email notifications or any other notifications, alerts are it will generate or not?
So we can configure it to have
Configure. Okay.
SMS notification. Apart from that, there is something called pager duty. Pager duty is when you have some high critical issues. It will send out a notification. It will create a call for your mobile. I mean, you can say that at any time you can call this number. Then it will make a call to you, irrespective of what time it is. So usually people who are in the support or SRE role, they usually get calls because they're in the high support.
Okay. Okay. Got it, Chintan.
Sure. Okay. Moving on. Okay. We have seen this particular stuff before. How do we create a auto scaling group? What are the different things required? Creating a launch template, attaching an existing launch template. Say include IAM role. That is like if you want to have some other configuration related to the spin up of EC2 instances. For that we require, I mean, we have already done it using the Terraform code. Since we have done all these things through Terraform code, we did not see exactly how to attach an IAM role. IAM role is all about to the EC2 instance, you can attach an IAM role that will take care of adding new instances or stopping an existing instance. So we also yet to look at the load balancer, but we have done with the auto scaling group creation and then minimum decide and then maximum count. Okay, so here target tracking policy that we spoke about it. If you set it at 50%, it will check for the total number of instances, whatever running instances, it will calculate the average for the total number of running instances. So this also we have already tested. That it will create a new instance when the CPU goes above 50%, goes above that particular percentage, it will add a new instance. Anyone has doubts with respect to how it is getting added? So in the target tracking policy, we don't need to attach any metrics or any alarm. It will automatically check for the CPU utilization. It will have an internal configuration that will check for the CPU utilization on each instance and try to get an average. If the average is more than whatever is mentioned over there, based on that, it will add number of instances. Again, if that comes down to this one less than that percentage, 50%, it will remove the instances, extra instances. So there are different ways we can also do it. I mean, creating an auto scaling group. We can use AWS CLI. We are currently trying to use Terraform for this. Terraform. And we can also use AWS CLI. That I'll show you how to get that particular code from the console itself. Launch template is all about setting an AMI, instance type, key pair, etc. And you can also do versioning. That also we have seen yesterday, but we don't have to really think about versioning at this point. So spot instances is like to save cost, because instead of reserved instances, we can go for spot instances. When we look at the EC2 instance types, we'll have a look at what is spot instances. Okay, here This one is what I was talking about. Target tracking is all about the number of instances running, but it'll add only one instance at a time. It will not add more than one instance. So step scaling, you can add based on the request. You can add either two or you can remove two. So this you can set it up in your configuration. This configuration also will take a look how to do a step scale. Scheduled scaling is all about at a particular time, say 9 a.m. in the morning or 9 p.m. in the morning, that I want to add 3 instances. Say 9 a.m. in the morning, I want to remove 3 instances. So like that you can do it. Predictive scaling is all about making the machine to decide, how much of instances need to be added based on the resource utilization. So we have load balancers like application load balancer and network load balancer. Classic load balancers are not required because that is out of scope. Health check for sure. We'll have a look. How does a health check works when we go to ALB, and we'll have 2 instances connected to the ALB, and the request will be forwarded through ALB to the instances, and it'll check whether the instance is healthy or not, and based on that, it'll route the traffic to the other instance. Okay, launch template creation, you guys are aware. So, like that's what we did so far. We have not created the load balancer. We just skipped the load balancer creation. We also need to have a target group which will talk to the instance to find out if the particular instance is actually healthy or not. It is like, say for example, if you are checking for port number 80, whether that is healthy or not, for that you need to create a listener rule. I'll say listener rule. That will be checking port number 80. For that, we need to attach a target group, TG, I'll put it here. This target group will go to the EC2 instance and check for this particular port is running or not. Port number 80 is running or not. Basically, in the load balancer, a application load balancer, you will have a listener rule. That rule will be written for a particular port number, and that particular listener rule will be attached to a target group, and then target group will internally go to the targets. So the target group is nothing but it'll be pointing to multiple targets. You may have more than one target running in your compute, running in your cloud. So this target group will keep checking whether both the services are running, both instances are running with the required set of services. Okay. So we have simulated the load, and then we were also able to see the number of instances increasing, number of instances decreasing. Any questions so far?
As of now, no, Shankar.